Welcome. This is BWR, Boiling Water Reactor, Generic Fundamentals, Thermodynamics, Topic 1, and it's called Units and Properties. Unlike components, we had 8 topics in components, and when we talked about motors and generators, if you haven't had components yet, this is probably new, but if you have already had components, when we talked about motors and generators, it was completely disconnected from, say, Chapter 2 of Sensors and Detectors, or even another chapter like filters, demins, and ion exchangers. We could talk about them essentially in any order. When it comes to thermodynamics, they all kind of build upon each other, all the topics. So it's really good to do topic 1, then 2, then 3, then 4. So having said that, we're going to go in order when it comes to units and properties coming first. It's topic 1. That's what we're talking about today. Thermodynamic units, topic 1. It is very foundational, this BWR GFIS topic for units and properties. It's foundational knowledge, essentially, for the rest of the chapters. So let's get right into it. I'm actually using topic 1, thermal units and properties, out of the Nuclear University indexed student guides there, and you have them available to you. And I'm on section 1.0, the introduction. And the introduction says, hey, the topic is going to talk about a system. And, you know, normally in thermodynamics, we'll talk about a system as being something that's being what we're going to call our working fluid. Most of the chapter will talk about the system as the working fluid. The fluid is water, and it receives energy, transports that around the system that we call, and it extracts energy out in the turbine, or we add heat in the reactor, or we reject heat in the condenser. And most of the times in classical thermodynamics, they'll talk about that working fluid being the system. We like to think about the pipes and the heat exchangers and the pumps and the valves being our system. So I'll usually talk about like that, and I will say, hey, we're talking about the working fluid now. Our working fluid in our system is water 99% of the time. Do we have hydrogen? Sure. Inside the casing of our generator, we have a working fluid of hydrogen. But typically, 99% of the time, we're going to be talking about our working fluid as water, right? So on topic 1 there, introduction, section 1, we're going to talk about units so that we can apply them. First paragraph there, heat transfer and fluid flow. Next thing it says we're going to talk about 2 things called enthalpy, and entropy. And boy, is this one a mishmash of understanding. So we'll look at entropy. And really what we're going to do is we're not going to talk about it in terms of its value. All we want to know is it going up, going down, or staying the same. That's all we want to know about entropy. It tells us a lot. Okay? Under section 1.1, right here on the lower left, you can see what we're going to use for units. So we're going to deal in American units. So we're going to be talking about pounds, mass, and feet, and seconds, and we're not going to be using the metrics, well, that's coming down to. All right? Over on the right-hand side, section 1.3, our working fluid. Working fluid. Typically, we will be talking about water, H2O. We know that we have a reactor, which is nothing more than a big heating element, that then transports steam to a turbine. That purpose of that turbine is to take the energy out of the steam and get rotation. Then we're going to remove energy in the condenser. This is our condenser. And then we're going to pump it back to the reactor. So we'll be looking at the process of what occurs here to here across this reactor. We'll look at the process that occurs there across our turbine. What is going on with the condenser, and then what is going on with this pump. And in each case, it's the same working fluid. It's water. Water gets turned to steam. The steam is sent to a turbine. Work is extracted out of, so energy is extracted out of the working fluid. We'll go to the condenser. We'll reject some heat to circ water, and then we'll raise the pressure of the working fluid. We will work on the fluid. So the definition right there, if you're looking, of a working fluid, it says it's a substance which receives, transports, and transfers energy in a system, a thermodynamic system. And you'll see a picture there that shows a reactor and a basic cycle. There's a variable heating element. Its purpose is to change the energy of the feed water to a high energy steam, and that high energy steam then will be sent to the turbine where we will extract that energy out and convert it to rotational work Then we will reject energy in our condenser, and then we will pump it up to the new higher pressure. On the next page, we start talking about properties. And some very specific things we need to talk about. Properties of the fluid. We're going to be looking at the properties of the second paragraph there, temperature, pressure, density of this working fluid. But then we're also going to be looking at specific properties. Specific properties. We'll also be looking at things that are intensive properties and extensive properties. These two are straightforward. Under section 2.1, these are discussed under section 2.1. It says an intensive property, an intensive is independent of mass. So if I had a bar of steel that was at 200 degrees Fahrenheit and its mass was 10 pounds mass, and I decided to cut it in half, so now I have 5 pounds over here of steel and 5 pounds over here of steel. They're both 200 degrees still. So the property was independent of mass. The temperature here is still the same regardless of what mass it was. And I could continue to further divide these, and it's still an intensive property. An extensive property does depend on mass. It says, last paragraph on the left, extensive properties may be changed to intensive properties by dividing them by their total mass. Last thing it says, when this is done, it is noted that the new property is considered specific. Oh, this is key. I can't emphasize this enough. When we talk about that entire cycle of the reactor, going to a turbine, then coming to a condenser, then going to a pump, that whole cycle there, what's going on with the water, this water circulating, which becomes steam and then goes to the turbine and then goes through like this, and it's just an endless cycle. All I want to know is what happens to 1 pound mass of either water or steam when it enters any one of these components. And if I know what happens to that 1 pound mass, I will just assume that that is what's happening to every pound mass that I send to one of those. Such that if I send 10 pounds mass per hour or 1,000,000 pounds mass per hour, the same thing is happening to every pound mass. That means it's a specific property. All I have to do to find out the specific change in the property, meaning I'm just going to find out what happened to 1 pound mass of the working fluid, and I can assume that that change occurs to all of the pounds mass that I send to it. All right, on to the next thing. That was section 2, properties. Very key. Specific properties are going to be super important.